Hello, welcome to Sigma Maths. We're going to be having a look at the exact trig values that you are expected to know in the non-calculator paper of the GCSE Maths. You are expected to know the exact values for sine and cos when theta is 30, 45, 60 and then 0 and 90. You have to know the exact values for tan for almost all of the same angles apart from the 90. Now, if you've watched the graph sketching video, the trig graph sketching video, you will already know the values of sine, cos and tan for 0 and 90. So we're going to be focusing in this video on the values of 45, 30 and 60. Now, I'm going to approach this by using some triangles that I actually think are quite easy to remember. And I'm going to strongly recommend that rather than just trying to learn them, because there are 9 of them, that you just learn the 2 triangles that I'm going to show you, and then you just do little sketches of them at the side of the question and rework out your exact values from your triangles, because you're not likely to get these triangles wrong if you've learnt them, whereas you are likely to just remember values the wrong way around. So let's start with the 45 degrees triangle. So what we're going to start with here, because we know we want 45 degrees, we're going to take a right angled triangle and we're going to make it an isosceles right angled triangle. The reason we're going to do that is it means that the 2 angles that remain in the triangle must be 45 degrees, because we've already got 90 degrees in the right angle, and we know that the total for the 3 angles in the triangle must be 180, and the remaining 90 degrees has to be split equally because we have chosen an isosceles triangle. Now, we can choose this triangle to be any size that we like, so it seems sensible to choose nice numbers for the shorter sides. Now, these are the sides that are both the same, and we just choose the value of 1 for both of them. Now, the hypotenuse is predetermined once we have chosen these 2 sides. We just need to use Pythagoras to work out what it is. So if we called this x, then we would be looking at x squared equals 1 squared plus 1 squared. So we get x squared is 2. So x is the square root of 2. So we've worked out using Pythagoras that if we have an isosceles triangle with sides 1 and 1, then the hypotenuse must be root 2. Now, once we've drawn this triangle, we are now free to write down the values of sine 45, cos 45, and tan 45. Okay, so sine, remembering SOHCAHTOA, just pop that up here to remind you. There we go. Sine is opposite over hypotenuse. So if we look at our little triangle, that is 1 over root 2. Cos is adjacent over hypotenuse. So we can pick either of the angles here. So for example, let's just highlight this one. Adjacent, 1 over root 2. Again, just like sine. And then tan is opposite over adjacent. So that's 1 over 1. We probably should have labelled these. If we picked an angle, let me just label these to make it even clearer. So this would be our opposite, this would be our adjacent, and this would be our hypotenuse. We know it's our hypotenuse because it's always opposite the right angle. So just to confirm, sine, opposite 1 over hypotenuse root 2, cos, adjacent 1 over hypotenuse root 2, and tan, adjacent, opposite 1 over adjacent 1. So we can simplify these. We're never going to leave an answer as 1 over 1 for a start, so that can just be 1. So tan 45 is 1. Now, these are okay to give as answers, but really we're likely to be expected to rationalise the denominator. So just a quick reminder there, the way that you do that when you have a single term is to multiply both the top and the bottom by the third, because the only way to get rid of a square root is to square. If we multiply along the top there, we get 2. If we're multiplying on the bottom, root 2 times root 2 squared. we just get 2 because the roots and the squares cancel. We're going to get exactly the same thing happen for cos, root 2 over 2, and we have already dealt with tan. So these are the values that the exam question will likely be asking you for. I'm suggesting that you don't try and commit to memory that these numbers go together, more that you just learn this isosceles right angle triangle, because it really doesn't take long to sketch this, and if you do it enough times, then you won't even have to rework out the hypotenuse. You'll just know that it's 1, 1, root 2, and then you'll be off. Okay, so that's 45 degrees covered. Now I did say that we're only going to be looking at 2 triangles, and that's because the 30 degrees and 60 degrees all fall into the same triangle. So this is the 30 and the 60. So this time what we start with is an equilateral triangle. The reason we're starting with an equilateral triangle is because that means we will already have a 60-degree angle. Now, because we want to write down trig values, we really would rather have a right angle triangle rather than this whole equilateral triangle. So we are going to cut this triangle in half. So draw a line straight down the middle. And what that's created for us then is our right angle, if we just take half of it. And because it was equilateral, I've actually cut the 60-degree angle at the top in half to get my 30. And that's why this triangle can be used to write down the exact values for 2 angles. So we had 3 answers from the isosceles right angle triangle that we drew before, and we're going to get another 6 values out of this triangle. Now last time we chose the sides of our triangle to be 1 and 1. I'm going to suggest something slightly different for this one, because one of the sides of the equilateral triangle is actually going to be halved, so we don't really want to choose 1 because then we're going to bring in fractions. Instead, we're going to choose 2 for this longest side here, the hypotenuse of the equilateral triangle, so that for the base down here, which is half of the length of one of these sides, we get 1. And now we're going to need to use Pythagoras again to work out what the remaining side of this triangle will be. So this time we know the hypotenuse, so it would be 2 squared equals the unknowns, we'll call that x squared plus 1 squared. So that gives us 4 equals x squared plus 1. Therefore x squared equals 3, taking 1 from both sides. X equals the square root of 3. So that's the last side there, the square root of 3. Okay, so let's write down the values of our trig functions now that we've set up our triangle. So we'll start with the 30s. So we've got sine 30, cos 30, and tan 30. So sine 30, that means we're focusing on this angle, and we're going to be using this as our opposite, this one as our adjacent, and this one here as our hypotenuse. In fact, this one will be the hypotenuse always. It will be the adjacent and the opposite that swap around when we change angles. Anyway, so sine 30, opposite over hypotenuse, 1 over 2. So that's just a half. Cos 30, adjacent over hypotenuse, root 3 over 2. And tan 30, opposite over adjacent, 1 over root 3. Again, we can simplify this like we did with the 1 over root 2 before, and in exactly the same way, we know we're going to get root 3 over 3. So that's by timesing the top and the bottom by root 3. So there we go. That's our 30-degree angle sorted. Now we're going to look at the 60-degree angles. So sine 60, cos 60, and tan 60. Okay, so this time, I'm going to change the colour. We're looking at this angle. So this one's our adjacent, this one's our opposite, and then, as I already mentioned, the hypotenuse is still the same. So sine 60 then, opposite over hypotenuse, root 3 over 2. Cos 60, adjacent over hypotenuse, 1 over 2. and tan 60. Opposite over adjacent, which is root 3 over 1, which we would just write as root 3. Okay, so we are spotting some nice things that are happening here. Our sine 30 and cos 30, if we were to swap the values around, we would get the values for sine 60 cos 60. So we have this sine 30 is equal to cos 60 and cos 30 is equal to sine 60. And that isn't a coincidence. It's all to do with the fact that the sine graph and the cos graph are related to each other by that 90-degree shift. I recommend that you have a look at the Trig graph video to see that. And then you'll also notice that your tan graph, your tan values are the reciprocal of each other. Yeah, so 1 over root 3 and root 3 are the reciprocal of each other. Now again, you don't need to remember, oh, sine 30 goes over half and cos 60 goes over half and etc. I don't think it's worth trying to remember that. Just learn this triangle. Quickly draw an equilateral, cut it in half, label your angles, label your sides, and then you can write down the values that you want. Now I mentioned at the beginning of the video that you would know your values of sine, cos and tan for 0 and 90 from your trig graphs, but just a quick reminder, 0 in each of them. Well, I'm sure you already know this, but let's just confirm. So sine 0 was 0. Remember, sine was the graph that started at the origin. Cos 0 was 1, because cos graph started at the top. And tan 0, well, we remember that tan is just sine over cos, so tan 0 would be the same as sine 0, also at 0. And we'll do the 90, so sine 90. If you ever go, oh, I just can't quite remember it, just give it a little sketch. Find somewhere on your page, draw a set of axes and go, okay, well, sine starts at 0 and it's a wave. Looks just like, well, it's not amazing, but you get the idea of the shape. That's 180, that's 360, 90, there. So we know the value of sine 90 is 1 because we know the highest that sine can go is 1. Cos 90, again, quick sketch helps us. Cos looks like this, ending at 360 here, 180 in the middle, 90 there. So it's 0. And we remember what happens with tan 90. It's not actually defined. Okay, so tan 90 was where we had the asymptote. So there is no requirement to know the value of tan 90 because, well, it doesn't exist. Okay, so that covers the exact values that you're expected to know for the GCSE Maths. If you found the video helpful, please click the thumbs up button and don't forget to subscribe if you'd like to see more. Alright, I'll see you in the next one. Bye.